Okay, I want to do a little bit of review first. First of all, here's a quadratic. It's got a vertex of 7, 9, and another point of 10, 30. I'd like to see if you remember how to write me an equation for that. There's a general form for the equation that you should know. Y equals A. See if you can finish that deal. If you don't know the general form, there's no way you're going to be able to get the rest of it. Forgotten that? This test is on Wednesday. You have today and tomorrow to get you ready. All right. So A, x minus h squared plus k. Raise your hand if you knew that. Okay, good. If you didn't know that, got to get it memorized. Next step, plug in all the numbers. That goes in for x and y. That goes in for h and k. Because only the vertex can go here, here. Then solve for A. It's a simple plug in chug. Plug it in and chug along until you got A solved. When you're done, just turn it my way and I'll tell you if you've got the right A term or not. Okay, I get you. So all I want right now is the A term. You got 3 different answers and they're all different. That means many people are doing this right. Okay, now that one matched up with somebody else. Probably right. That's the 3rd time I've seen that one. That's probably it. Yep, that's it. Okay, good. I agree. I think that's it. I don't think that's it. I think you got the top right. I think you left off the denominator. I think that's good. All right, a lot of people are having trouble, and it's good for me to know that at least. Here's what you should have done. You should have put in, okay, the y is 30. See, that's the y. That's the x is 10. Any clue what that would be? A rap battle. All right. Anyway, this is where the 7 and the 9 go. So final answer 30 equals A times 10 minus 7 squared plus 9. Raise your hand if you had it that far. Okay, good. Then you just have to finish the deal, and this would be 3. 3 squared is 9. 30 equals 9A plus 9. You subtract 9 from both sides. 21 equals 9A. Divide by 9. 9, and I have 21 ninths, which isn't quite reduced all the way. So we just have to take 21 ninths, say 3 goes into both of them, 3 goes in there 7 times, and 3 times 7 thirds. Okay, now do you get, though, that A, being 7 thirds, is not the final answer? All we did is we found A. We found this. So now we go and rewrite the equation. Y equals 7 thirds, and then x minus h squared plus k. And this time, you write it with just the vertex in h and k, which were this, 7 and 9. So this is a minus 7, so it's the opposite of that number. And there's your answer. 7 thirds, x minus 7 squared plus 9. Any questions on that one? Yes, sir. Okay, so the problem that you have then is you think h is negative 7. That is just a plain old positive 7. You're making a mistake in your logic, okay? You're in a circular reasoning loop. So, what this? Would you agree that that is supposed to be a positive 7? Okay. Then, do you get that this right here is always supposed to be the opposite of the number you use for your vertex? Okay, so do you get how if I take the vertex on what I wrote right here, that the vertex would be 7, 9. That's why we need that to be a negative right there. Okay? Okay. All right. Gotcha. Okay. I think the formula does work, though, the way I have it. So it's not supposed to be a plus h right there. It's supposed to be a minus h. And so if we put in a positive 7 right there, it will work. Okay. Anyway, let's move on. That was one kind of problem that you needed. Another kind was a simpler kind. I give you 2 points. F of 3 equals 7, and f of negative 2 equals 9. Now I just gave you 2 points. Now what's the straight line that goes through them? Give that one a try for a second. Find the straight line that goes through those 2 points. Pause for a second while you do that. Okay, so here's what you should have done. You should have said that's 3 comma 7. That's negative 2 comma 9. And I know this formula, y minus y1 equals m times x minus x sub 1. How many of you actually used that formula in this process? Good, that's the one I would have recommended. You could do it other ways. Now I'm going to find the slope, which is right there. Now I can do this the exact same way. I can plug in all 4 of these numbers into this formula right here. And I just have to pick which one I want to be which. I'm going to say this is my x and my y, and this is my x1 and my y1. And now I can just plug them all in and solve for m. I personally, though, think most of you have learned to solve your slopes this way. 9 minus 7 over negative 2 minus 3, which would be 9 minus 7 is 2 over negative 5. So your slope was negative 2/5. How many of you had that for your slope? Okay, good. And now the y minus and the x minus go like this. I can pick either point. I'm going to choose that one to be my x and my y this time. So my x is going to be 3, and my y is going to be 7. And there's a good answer. Could you have put negative 2 here and a positive 9 there? Yeah, if you wanted to do it that way, you could have. It would have been y minus 9 equals negative 2/5 x minus negative 2, which you really like x plus 2. Either one of those two is good. Okay, next topic. Let's talk about graphing. We haven't talked about that in forever. This next test is about communication. So we can ask you things like, tell me or describe to me what this equation would look like. In other words, it's not a graphing test. We'll get at least to make you identify some different graphs and say, well, I hope you remember this one, the parent graph for it. Would you sketch? I'm going to make a big list for you. And I would recommend you keep this someplace and study it before you take the test. Okay? X squared. That should be like, doing this forever. X squared. Duh. Okay, but did you know that x to the 4th, x to the 6th, and x to the 8th would all look about the same? Take your graphing calculator out if you haven't already. And I want you to graph y equals x to the 4th. I think you're going to find that it looks a lot like x squared, just a little bit steeper. All the even ones, x to the 4th, x to the 6th, x to the 8th, x to anything even, kind of look like parabolas. All right? How about this? Y equals x to the 3rd. And, of course, along with that, x to the 5th and x to the 7th. They all look about the same. Do you remember what their parent is? You could always sketch it if you want to verify that I'm not losing my mind, which might be a good idea today. But you don't have to. That is all of the x to the odd power. Okay, here's another set that, so there's those two you kind of knew because you knew what x to the 2nd and x to the 3rd looked like. So if you can just now associate it to any even one, x to the any even thing, just like x squared, and you're good on that. And x to any odd thing generally looks like this. It just gets steeper and steeper, like tighter and tighter stretched when you change it to 5 or 7. In other words, x to the 7th might that super Because when you take, we put in 2, you got to go 2 to the 7th power. It'd be over 2 and up like, I don't know, 100 something. Big number. Okay, so the next couple, I need to make a list for myself to remind myself because there's all these weird ones. Y equals x to the 1/2 power. Do you get that the 1/2 power really means square root? All right. Do you remember kind of what square roots look like? Okay, kind of like that. So are you going to remember that x to the 1/2 looks a lot like, take a guess here. The next one I'm going to write x to the 1/4, which is going to look a lot like x to the 1/6, etc. Okay, you think you're going to remember this later, but you're not. I'm a math teacher and I get confused on these myself, so if I were you, I'd be taking notes right now. The fourth little family I recommend you write down, and this one is unlike anything we've seen, is I like to call it the volcano. Okay, this one a lot of people call the snake. This is called a parabola. This one I've called the ramp before, but you don't really need to know these names. But this next one I would call the volcano. And it looks kind of like this. It's got 2 parts to it. Just like, I don't know if you remember in the old days, we used to have the graphs that would go like that. That. Okay, it's kind of like that, except this part is up there. Okay. Anyway, that is y equals x to the -3rd and x to the -5th and x to the -7th, etc. They're all volcanoes. Okay. Now, we've done even fractions here. We've done even not fractions right here. We've done odd not fractions, I guess you'd say. Now we should probably do odd fractions. So I'm going to move these down to like the next row so that I can put odd fractions next to the odd whole numbers. So here's a little sketch for you of the family of things like this. X to the 1/3 and x to the 1/5 and x to the 1/7. All right, so I am going to take the same graph that was like, this is x squared, right? Do you remember the x squared one? But with x to the, the square root, sorry, like 1/2, y equals x to the 1/2. This is y equals x to the 1/2. And the x to the 1/3 is a lot like that. It's just that, remember how square roots, you can't have negative numbers, so thus we don't have anything over here. But with cube roots, this is something to the 1/3 power is like a cube root. It's sort of like the cube root of 8. Do you remember that you can have negatives underneath cube roots? Because like the cube root of -8 is -2. There is answers. It's not like, oh, wait a minute, it's a square root of a negative. You can't do that. On this kind, there are answers. So, moral of the story, your final answer is, it goes in both directions. It's like a square root, sort of like the x to the 3rd one, except flipped. And it's going this way instead of x to the 3rd, kind of like that way. So anyway, there's your x to the 1/3, x to the 1/5, x to the 1/7. All right, they all kind of look about like that. The bigger the power is, the tighter it gets to the axis. So the x to the 1/7 is probably more like this. All right. Now, last ones that you better write down. We've done even and odd poles. We've done fractions. We've done negative odds. Last one we haven't done, there was the negative odds, is the negative even powers. So, like this. Y equals x to the negative second, and x to the negative fourth, and x to the negative sixth. And on this, I'd like you to think of what to the negative power means. So for just a second, take a little walk with me. If I said 2 to the second power, that's a simple one. What is 2 to the second? 4. But what if I make it 2 to the negative second? It makes it 1/4. It's like 1 over 2 to the second. So this negative in the power makes your answer 1 over whatever it was. So if you understood that, then try to figure out for me, what's 3 to the negative third power? Don't say it. Think it. What would 3 to the negative third power? Hopefully you just did 3 to the third in your head and got 27. Then what do you do? 1 over that. It's 1 over 3 to the third. So it's 1 over 27. Okay? All right, so that's what's really happening there. So when I have y equals x to the negative 2 power, that's the exact same thing as if I said 1 over x squared. Do you remember graphing the fraction function? The ones where we said, like, oh, it's bigger on bottom, bigger on top, same on both, those kind of ones? All right, fraction functions, the rational functions, are these. These guys are the ones that make these. Simplest of them all was the odd ones. Oh my gosh, I made a little mistake here. This is good to correct this now. Okay, so this one, these are the ones that are supposed to go with this graph. Sorry. The volcano is these guys, so I got to reverse these two. So here, move these over. It's not that hard. Just change your little 2, 3. You change your little 3, 5, and 7 to 2, 4, and 6. And change those to over there. There we go. Delete it. Like it never happened. Thankfully, the only mistake on the pictures so far that I've found, anyway. Okay, sorry about that. So this one is the this is the one for the even ones. This is the one for the odd ones. Double check that. Okay, yep. Double checked. I know that I'm right now. The volcanoes are the ones that are the even ones. The odd ones are the ones that we already knew before, where you got some part of it's up here and the other part of it's down here. All right. Now, since this is not a graphing test, you do not have to be able to, like, make accurate sketches of all of these things. Okay? But if right now, for instance, I were to say, all right, this is a part of a graph, and I don't know what's on this side because I can't see it. All I know is it's got that in it. Tell me the 2 graphs this could possibly be. Don't say it. Write it. What are the 2 graphs that would have that part on it? Yep, good, good. I would like to see. I'll try if you're right or not. You're on the right track. That works. That works. Yes, but what are their names? Like y equals what? Yes, 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 yes. I like that way of saying it. Good. Yep. Yep. So y equals a x to the any, like, negative, or odd or even. That, or any even number here, or any odd number, would have this component to it. Now, what if I knew the rest of the graph? I knew the rest of the graph was that. Now, which one? Gotta be one. Only one. Yes, 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 yes. Perfect. That was Jingle Bells, in case you didn't notice. Yes. Okay, so that was an any even. So it was y to the negative even power. 2, you could have said 4, you could have said 6. All right, and that's the volcano one. How about this? What if I got something down here? What could that be? Say that I didn't know what's on this side of it. I just know there's something down there. Use your big brain. Try to use... There you go. Yep. Close. Norm. We need to somehow get something... There's no normal graph that would be down here. That is not any of the ones I told you before. You have to do something to them to make them go down there. There you go. Yep. Work. Yes, that would work. Yes, that would work. Yes, that would work. Yep. Good job. That would work. That's one of your possible answers. There's more than one possible answer. Yes. There's more than one possible answer. Yes. Got one of them. And let me see. Yes, that works. Works. That's one of the possible answers. Okay. So, here are the possible answers for this one. I think you all get that that's the thing I was doing and taking that and flipping it, right? So really, what was the answers for that red one before? It was either x to the negative 2, or it could have been x to the negative 3, either one, right? But what did I do to it? I flipped it up, down. So therefore, it needed a negative in front on both of them. So it could have been any even powered like this, or any odd powered, but it would have to have a negative in front to make that work. All right, I think we've covered the graphing section ad nauseum. So now, we will go to the last part, which is using the graphing calculators again. So we get into stat mode. What we're going to do is do a power function. And instead of just making up a random one, let's do one from your worksheet for today. So everybody find 2.2.2. Here it is. And I'll do the first few problems with you, and just have your calculator ready so that when we get there, you can do the power functions with me. Everybody's got access to it on their iPads. 2.2.2. It's in the normal spot. Remember, this is Unit 3, weirdly. I think it's Unit 2, but Unit 3. Okay. State the power and the constant of variation. Do you remember these? That is the constant of variation. That right there is the power. It says graph it. Ooh, we just learned about those a few seconds ago. Now this stretch factor of 2, don't make that stress you out on the graph. Okay, so just graph x to the 4th. And if you think of it, when you're graphing x to the 4th, which by the way, hopefully you remember or you look at your notes, is basically just a parabola. If you wanted to make this stretch factor, all you're going to do is stretch it even more. The vertical stretch factor 2. So I guess you'd make it a little tighter than what you had before. Okay, so what if there's a negative in front? Is that okay? Yeah, that's no big deal. This is the constant variation. And then the power is 3. No big deal. How about the graphing it part? Graph it and then status, domain, and range. Well, if I generally have this graph for this picture right here, and it's stretched up a little bit, just make it a little bit steeper maybe. That's about all you got to do. Don't worry about that. Then domain and range. Domain, that's from left to right, all reals. Range, that's from low to high. That's a little more tricky. What is it? Yes, so you could say 0 to infinity can be 0. There we go. Okay, this guy's graph. Ooh, it's an odd one. What were the odd ones like again? The odd ones were like this. If I stretch it with a negative, ooh, the negative is going to change it. The negative is going to make it like this, and the stretch is going to mean it's like pulled a little tighter. So there we go. The green one is my sketch for number 2. And then it's domain and range. Domain is this way to this way, that way to that way, and it goes forever in both directions, so the domain would be all the reals. And the range would be from low to high, and it goes forever in both directions there too. There we go. Alright, so these are not impossible. Let's move on to the next couple. I'm not going to do all of these for you, but hold on a second. Okay. Come on. There we go. Okay. This one, first thing, you got to rewrite that puppy. You know how to? Y equals 1/2, we say. X to the what? Not negative fourth, 1/4. The roots go on the bottom. That's a fourth root, right? And the roots go on the bottom. Try to remember that. It's just like in plants. The roots go on the bottom. Okay, so now that I got that, constant, what's that guy go? Power. This is COV. Alright? Again, a pretty simple one here. The only thing is we want you to get a sketch now. If I wanted to do a sketch of this, this is x to the 1/4 power. You might want to look on your notes, but if you can remember, that's just like x to the 1/2 power, right? Because it's an even fraction. And you know that one, that's the square root, right? So it's pretty much just a square root. Except it's been shrunk a little bit, but you can't even tell the difference if I put a 1/2 factor on that. It's a little bit lower than it used to be. Alright, so it's still going to look basically the same. Okay, so there's your little sketch of it, and now the domain and range. Well, once I have the sketch, the domain and range is easy. Domain's how far this way to that way. That'd be 0 to infinity. And then the range is how far this way to how far that way. I think you could handle those. Alright, move on to the next kind of question you expect to handle. Describe the transformations in the correct order. This is just simply order questions, and since it's so simple, I'm going to allow you to skip 5, 7, and 8 here, because there's more underneath that we can do. Okay, so on number 6, there's only one thing to describe. And is that 5 times wider? Well, that's the common gotcha answer. Instead, 5 times what? Smaller which way, though? Horizontally or vertically? Yeah, horizontal and inside, right? And so this is horizontal shrink factor 1/5. Alright, and the next 9 and 10 are where you can actually do some serious practicing. Just make sure you use the correct wording. On number 9, this is very commonly misunderstood that to be inside, that is not on the inside. That 1/4 is on the outside. It's high vo, vertical on outside. Alright, moving down to these guys. This is where I was doing all that practice because you have to be able to pick out which graph is which out of this lineup here. Now, if you took good notes before, then when you look at this, you'll be able to say, okay, it's an x to the 4th. I know what that looks like. It's like a really tight U shape. And then, wait a minute, the 2/3? Oh yeah, server said to not worry about the stretches too much because you can't really tell much difference on a sketch. Okay, so then I'm not even going to try to sketch that different. But what about the negative? Will that show up on the sketch? Oh yeah, that's going to make it flip. Which way? horizontal is on the inside, vertical is on the outside. What's this one? Vertical. So it's a vertical flip. So basically, that's gone now. That looks something like that. Okay, now notice in the picture above, remember how I kept doing like, what if you couldn't see this? That's what they do on the pictures above. So that little sketch I just made there is my idea of what it should look like. Then I got to look up on the sketch above and see which could that possibly be. Well, my sketch is in the lower quadrant, not the upper, okay? And it's this part right here, right? So which could that be? Does it look like the blue one? Clearly it's not the red one, because the red one doesn't have any curve to it at all. Or the green one, or the black one? What do you think? Blue. I think it's the blue one, so therefore it's G. Okay. So if I were you, how I'd handle these is I'd make a little sketch of what I think it should probably look like, and then go up to the graph and figure it out from there. So what should that one look like? Well, that's an even root. Is that the volcano? Isn't that the volcano? Is it? It's the one I got messed up before. Help me out, is it? Okay, good. Alright, so that's the volcano, and then, remember, we can't see this side of the graph, right? We don't have to worry about that side of the graph. And then, what is that going to do? Remember how the stretches, you can't really even see the difference on a sketch? So don't worry about the stretch. Last thing we got to worry about is the flip. So then basically it's something that looks sort of like that. Hopefully you'll find something that looks sort of like that. Alright, enough of that. I'll give you a little something to practice on your homework. Now this one, it should seriously be super easy. We've done linear regression. We've done quadratic regression. Now you're doing cubic regression. So you put the info in, just like you normally do, under stat. And then instead of selecting linreg or quadreg, what do you think we pick? Cubereg, and it's the same exact kind of problem. Okay, so I don't want to spend a lot of time teaching you that because I've already taught you that twice. Now I'm going to go down, though, that one that's kind of weird is power regression. So I actually want to let you do 16 later because it's super simple. But let's do number 17 together right now. Velma and Daphne gathered the data in the table below using a 100-watt light bulb and a calculator-based laboratory with a light intensity probe. So basically what they're saying is, how intense is the light as you get further and further away? Does it make sense that if you are closer, like only 1 meter from the light, that it would be rather intense? Compared to 3 meters from the light, it would be not nearly as intense. You get how you get really, really close to the light bulb? It's like, oh my gosh, like, can't see. Okay, so this data makes some sense. Then you just type in the data. Let's go ahead and put that into the calculator. I'll pause for a second while we put that in your stat edit. Okay, so I got the question, does it matter which way you put the data in? And yes, this has to be your x's, this has to be your y's. And the way I can tell it is if you put it this way or you look at it this way, either way, what's the first number you would type in? Off either one of those charts, what's the first number you type in? 1. And that is your x. So just take the first number you would naturally type in, whether you're looking at the chart this way or the chart this way, and the first number you'd naturally type in would be the 1, or the 1.0, right? That's your x. That's how you know what x is. Okay? Another way to think of it is, the x is the top row, and the x is always the left row. But I kind of like that idea of take the first number that you would normally type in on the chart, naturally. You'd never start at the bottom and then go to the top, would you? So, anyway, that's the first number I would pick, and that's the first number I would pick, and I'd always make those the x. All right, so let's pause for a second and look at the data in. Okay, we got our data in here. Now I'm going to go to stat, calculate. Now, which of these looks like a power regression to you? None of them. What the heck? You gotta scroll down. In fact, the fastest way is to actually go up. If I arrow up, I can see all the rest of my choices. See what I'm saying? You can go up from either from the you can arrow up and find it, or you can arrow down. But of those choices, do you get PWR reg, power regression? Okay, and it says right in the problem that they're supposed to use a power regression. Here, I'll like to make this the underlining of it. Just find the power regression equation right there. Okay, so power regression, so I know to use power regression. And boom, there it is. Same kind of a process. If you don't have the fancy operating system, here you type L1, L2, Y1. I have the fancier operating system, so I just got to go here and go vars, Y vars, enter, enter. And I'll go down one, calculate, and hit enter. And if it froze right there, I would go back to my y equals screen and erase that equation that was there. But this didn't freeze, it worked. And if I were to write out what it's saying my equation is 2.64, and yes, I'm just rounding there, x to the negative 1 or 0.1277. There's my power regression equation, and yes, I rounded it. Ideal world, you wouldn't round it, but if you're supposed to write it down on your paper, I'm fine with you rounding it. If you actually need to calculate something, like in part B, then I'll show you that next. Uh-oh. Alright, the y equals. Okay, then I might have typed in some data wrong, so let's go to stat. Wait a minute, stat, edit. See if there's a chance that I had some data messed up in there. You see anything on my chart that's wrong? Right there? Oh, okay. Alright, thank you, I'll record that. Oh, I am recording the whole time. Alright, so we found a mistake in this. It's supposed to be 1.5, instead I have a 15 there, so that's why my equation came up goofy. Sorry about that. I swear I typed the dot, but it must have missed it. Alright, so now that gives me new data. I go back to stats, see how quickly I can do this. Calculate. I'm going to arrow actually up to get to power reg. It's right there, power regression. Enter. Go down, put a Y1 right there. Vars, Y vars, enter, enter. Enter, go down, enter again. Okay, please tell me you had this one. 7.931 and negative 1.98. Okay, good. So then I'm going to cut right to the chase, which is, what question do they want? Use the regression to predict the light's intensity at a distance of 1.7. How do I know which one distance is? I know distance because it says right in the problem, distance right here. They're telling me an x. So they told me x is 1.7. So I'm going to go into my table, and my x is 1.7. How do I get my x's to count nicely like that? I want x to be 1.7. I better go to table settings. Have it start at 1, and then count by 0.1s. Then I can go back to my table. That'll probably be the hardest part for you, is to like adjust your table. So now that it's like that, x is 1.7 is no biggie. It's right there. I arrow over to get the exact answer. Notice it's rounded in the chart. The exact answer is 2.76280892373. And yeah, I would write them all out. I double check it to make sure you didn't copy something wrong. Okay, there is an answer for your worksheet for today. And that's an idea of what you'd have to know from the test. Okay, so I covered a lot of stuff. I'm glad you were paying good attention here. And we did do a decent chunk of your worksheet, so what you have left is yours to handle. That's all I have for today.